Programs that manipulate numbers are all well and good, but oftentimes we're going to want to be able to work with text and words as well. To help us do this, Java defines the character, or CHAR, primitive type. Characters are the smallest entity of text that you can work with on a computer. We can think of them to start off with as single letters. Let's start building our program by simply defining a single character. We'll call it character 1, and we'll assign to it the value of uppercase H. Just as we have to use some extra syntax when defining a floating point number explicitly, we need some extra syntax when defining a character. To tell Java that we're explicitly declaring a character value here, we surround the letter we would like to assign to our variable with two single quotation marks. The single quotation marks, as opposed to double quotation marks, let Java know that we're working with a character, a single letter, as opposed to trying to use an entire string. Characters can only have single entity values. If we attempted to assign the value of high to this character, NetBeans and Java would both let us know that that's not a valid option. Now, let's move on and write a somewhat convoluted program that will nonetheless work pretty well for our example purposes. Let's define 5 characters. We'll call them characters 1 through 5, and we'll give them values that when printed together will show hello. In the second portion of our program, let's use system.out.print to display these values to the screen. System.out.print works just the same as println, except that it doesn't add a carriage return at the end of our line. Actually, let's have the last command be println, so that our output is separated from all the additional text presented in our console. So if we run this program, it greets us. It says hello and then additional text. So that's pretty straightforward. Now let me show you something that will give us a little insight into how our computer thinks about characters. It turns out that we can set the value of character 1 not only by explicitly declaring capital H between two single quotation marks, but also by giving it an integer value. Each possible character value has a corresponding number that we can use in lieu of it. If we replace our single quotation mark capital H end quotation mark with the value of 72, we're still going to print out capital H ELLO. If we were to use the value 73, 1 greater than 72, instead of a capital H, we'll now get a capital I being the letter that follows H in the alphabet. Make sure you don't put the 72 between your single quotation marks. Best case scenario is that Java recognizes that 72 is not a valid character. That looks more like 2 characters. And then our program won't compile. If we were using a single digit number, our program would compile just fine, but we would get the completely unexpected 7 ELLO word. So how do we figure out the numeric value of characters? Well, there's a universal lookup table, the ASCII table, which maps characters to their numeric values. In this video, we've been dealing with columns 1 and columns 5, which have the decimal number and the character that they map to. You'll notice that while many of these characters are letters, others are keyboard symbols, numbers, and other things like tabs. As far as programming languages are concerned, new lines, tabs, and backspaces are all character elements. To see this in action, let's try replacing some of our characters with the decimal value 9, which should correspond to a tab character. If we replace the middle 3 letters of our word with tabs, we should expect as output H, 3 tabs, and then O. Thanks for watching.